If there are no questions, let's go to the last topic of the session. I call upon Dr. Vinod Tewari, the role of 10,000-fold effect in improving leg cramps in myelopathic spinal cord changes. Dr. Vinod Tewari, please.
Good afternoon, everybody. So now I am presenting this 10,000-fold effect, its effect on myelopathic spinal cord, which causes leg cramps. This is just a case study with just 5 months follow-up. As you all know, synapse. This is basically synapse and integrate neurotransmission coming from this side to this side, and after reaching synapse, it releases glutamate, which acts on NMDA receptor, and this integrated neurotransmission goes beyond it. In turn, it releases nitric oxide synthetase, NNOS, which causes release of nitric oxide cloud at the level of synapse retrogradely. This NO is being taken up by the heme of this nitric oxide receptor, and this affinity is more than 10,000 as compared to the oxygen and hemoglobin at your alveoli level. That causes smooth muscle relaxation, and thus the cerebral blood flow or the neuronal blood flow and the integrate transmission is being either activated or degraded. And then via AMP that causes LTP, that is long-term potentiation for learning and memory. So this whole integrated neurotransmission with glutamate, with an NMDA receptor and retrograde regulation that causes the blood flow regularity at the level of NVC, neurovascular component. So after getting a little idea about 10,000-fold, just have a consultation of in muscle leg cramps. So muscle leg cramps in cervical myelopathic change is inconsistent in symptoms that cause vague symptom from funicular pain to muscle atrophy and cramps. And later on, it is very disturbing to patients, especially in nighttime while taking rest. If we get any compressive myelopathy, definitely you have to operate, but in non-compressive myelopathy, which is basically due to dynamic or vascular injury, and that too, especially in oligodendrocytes, leg cramps are very disturbing. So there is a considerable evidence exists to support ischemia as a major underlying pathologic event contributing to myelopathy and thereby leg cramps. So as far as the blood supply is concerned, from anterior compression that causes the anterior cervical arteries, and the posterior that causes compression of the intermedullary branches and central gray matter. And thus, nitric oxide is being generated by nitric oxide synthetase, which acts via 10,000-fold effect to reverse the neuronal damage. We used intrathecal sodium nitroprusside to activate the 10,000-fold effect to modulate the retrograde neurotransmission in muscle cramps in cervical myelopathy. But this is just a single case. So the main pathology is that synapse via insufficient glutamate transport that induces motor neuron death due to repeated dynamic injury, especially flexion extension. So NOD, a nitric oxide donor, in our case it is sodium nitroprusside, that releases nitric oxide which causes modulation of integrated neurotransmission via RNT, that is retrograde neurotransmission by 10,000-fold. Thus increases the integrated neurotransmission impulses in those defective synaptic portions by bypassing the routine integrated neurotransmission impulses. So there was a lady of 32 years old, normal sensorium, but was planned corner given every very important after fifth day of ITSM thereafter. So this was the single case. So we have got the 10,000-fold effect via pico-nanosecond absorption spectrometry, PENSAT, the non-available changes to temperature. So just a simple conclusion that in a well-diagnosed cervical myelopathy and leg cramps, ITSMP induces 10,000-fold. That causes no leg cramps, and after fifth day, up to now, that is fifth month of follow. These are the references, and this paper is published in ACTA Scientific Neurology. Very, very thanks and for patience hearing.
So I think the radiological part they have skipped too fast. So there was a cervical myelopathic change at the level of cervical spinal cord. That was the main cause of this muscle leg cramps. So we have tried